Welcome to Aspirants. Myself, Soumen Chakraborty. I am an assistant professor in the Department of Mechanical Engineering at Vignasa Institute of Technology. Now, first we will start today with the topic of strength of materials. Now, in the subject strength of material, we come across many modules, and the first module is simple stress and strain, which is the most basic module of strength of material. Okay, so what is simple stress and strain? Now, firstly we have to discuss the topic strength of material. Now, strength of material comes under the sub-branch which is named as applied mechanics or engineering mechanics. Now, engineering mechanics may be divided into three subcategories. Now, if EM, I am writing those in short forms. EM means engineering mechanics. Now, I can divide it into three categories. First one is rigid body mechanics or RBM. Second one is deformable body mechanics or DBM, and the third one is fluid mechanics or FM. Now, this deformable body mechanics we can term it as strength of material, which is our full course. Now, let's start. Now, as you have all taken the notes, I can erase this part, so I am erasing it. Now, let's come to our module, which is simple stress and strain. So, before knowing what is stress and what is strain, all those stuffs, first we need to understand from where we got all those terms. Now, suppose this pen, this is also a body. Now, we can apply force on this body in many ways. First one, we can pull the body. Secondly, we can push the body. We can twist the body. We can break the body by applying load in this direction. And all those type of loadings, which is nothing but mechanical loading, can lead to many types of stress and strain. Now, what is mechanical loading? Mechanical loading means whenever we are applying any force to a body, if the force is directly applied on the body, then the load is termed as mechanical load. Now, this type of load leads to stress, and the results of those applications results into strain. Now, strain is a measurable quantity, stress is not. Let's start. Stress. Now, we all know that all those bodies or members or materials consist of many molecules, and all those molecules have some atomic bonding and those stuffs. So, while applying load to a member, suppose this is a member. As you can see, I am drawing a axis line. That means it is a cylindrical rod. Now, I am applying load in this direction and this direction. This type of pulling load is called tensile loads. We will come across all those type of cases. Firstly, let's discuss what is stress. Now, while applying load on that body, generally the body gives some sort of resistance because of its intermolecular bondings. Now, those resistance leads to stress. Now, guys, you can make a note that what is stress? Stress is nothing but the resisting force applied by the body per unit area. So, you can say what is stress? Now, let's make a section over here. Suppose this is a section. Now, I am dividing the body. Suppose the body is AP and I am applying a load P over here. Now, whenever we are making a section from here, it will look like this up to the section. Now, this force is P and the body is giving some sort of resistive forces, which is nothing but F. Now, as per Newton's law, we know all the body gives equal and opposite reaction forces, which is nothing but Newton's third law. So, this body is giving some sort of force P and this resisting force F, and this is P. Now, this resisting force is coming from all the molecules which are present in this cross section. If you have missed what is cross section and what is oblique section, whenever we divide the body or we or in transverse direction, that type of whatever type of section comes out, it is called cross section. Now, if we cut it like this about an angle, then the section will be called as oblique section, and this angle by which we are cutting the body is named as obliquity. So, whenever obliquity will be equal to 90 degree, the section will be termed as cross section. Okay. Now, this cross section area is giving a force F, and as per Newton's law, we know P. This F is given by all the molecules. So, total F will be equal to P. So, you are applying force load P, which gives to a resistive force F, and this F and the P are equal. So, now what is this? Now, throughout the cross section area, each and every molecule is giving the force F. So, there will be an infinite number of delta F. If we sum them up, it will lead to total force F. So, the delta F is coming from all those areas over here. Now, make a note that the stresses at each and every point is not equal. Okay. So, but we need to find out. So, we use another term which is called average stress, which is sigma average, and the sigma denotes stress. So, sigma average is given by the total body, and each and every molecule or each and every point of that body gives an average stress, which is sigma average. So, F must be equal to total average stress into total area A. Now, this derivation you can also do by using differential calculus. Suppose a small amount of area, which is delta A, is given a small amount of force, which is delta F. So, we can say sigma is equal to limit delta A tends to 0, delta F by delta E. This sigma is not same throughout. That's why you are using the term sigma average over here. Now, as you can see, so if we differentiate or if we remove the limit, then this delta sigma will be equal to dF by dA if we remove the term delta from here. So generally from here we can say dF will be equal to sigma into dA. If we integrate it throughout the body, 0 to F dF equals to integration 0 to A sigma dA. So you can say there is got a term sigma which is not same throughout. That's why you introduce the term sigma average over here. To make it clear for you guys, I have done the whole derivation. You can see it over here. So whenever we use the term sigma average, you can see these two equations will be same. Okay. So now I guess you all understand what is stress. So if you got any queries up to this point, you can use our comment section. You can comment your queries and we will clarify all of your doubts. Okay. So as you can say, F equals to sigma into A. Now we have already discussed that F and P will be equal and opposite in nature. So we can replace F by P. So the actual definition of stress is resistive force per unit area. As you can see, if we divide it like this, sigma will be equal to P by A. Now this here is a resistive force, that's why you use the term resistive. Now many students made a mistake while introducing stress, they named force per unit area. This is wrong. Force per unit area is another one term, and we will come across that in our further modules. That is nothing but pressure. So always remember one thing: stress is resistive force per unit area. Always, this is the most important term in the definition of stress. The resistive is resistive force. Previously, I have told you that there are many types of loads that can lead to stress, like pulling, pushing, twisting, and all those type of loads are named a particular way in our topic, which is strength of material. So first, in our previous case, we have used this type of loading. This is P, this is P. This is the first case. Now, this kind of loading we named as tensile. Now, tensile load leads to tensile stress. Okay, this is the first case. Now, second case looks like this. This kind of loading is named as compressive load. Compressive load leads to compressive stress. Next type of loading is if we apply load like this on a section. This type of load you can see in your you have used scissor, like in scissor we use this type of loading. This type of loading is called shear load, and this load leads to shear stress. Now in shear stress, as you can see, there are two opposite loads. These two must be equal, and the line of action of those two loads must not be same. They should not coincide, these two line of actions of these two forces. Okay, this type of load we call that shear load. Similarly, if you try to bend the member like this kind of load is called bending load. If you try to twist it, it also leads to shear stress, but this kind of load is called twisting load. Okay, so we have learned tensile, compressive, shear, bending and twisting type of loads. Now twisting loads, I guess all of you have studied engineering mechanics really well. Otherwise we will make another one video on engineering mechanics, you can go through that. So twisting is nothing but applying two equal and opposite movements. You have seen, you have watched your mom while washing your clothes. They used to twist the cloth like this. This type of applying two equal and opposite movements called twisting loads. Okay. So we have understand what is stress. We have gone through different types of stress. Now, as you can see, stress is a resistive force, is an internal phenomena, so we can't quantify that stuff. We can quantify that stuff by dividing your load per unit section, but it is very difficult as it is an internal phenomena. You can't just cut the body and trying to find out stress at each and every point. For that purpose, you have another one term which you can quantify, and which is known as strain. Strain, what is strain? Strain is nothing but the result of application forces on a body. Like body of length L. Okay, and we are applying some loads. You can say these are two layers of the body, which is A and another body. Now after applying the load, the body will get stretched. This is a tensile load, as you can see. So the body will get stretched. Whenever the body will start stretching, these two layers of the body will start separating from each other and the distance will increase. So generally you have an elongated body like this, some length of say delta L of elongation we will get. This delta L of elongation is called elongation. Suppose you have a member of 5 meter length and the elongation is 0.5. 5 meter and elongation is 0.5 meter. So the strain is nothing but the deformation, the ratio of deformation to the actual value of the dimension. Like in this case, the strain is always denoted by epsilon, and epsilon is equal to delta L by L. In this case, it will be 0.5 by 5, which is nothing but 0.5. Strain doesn't have any units. Always remember that. In your many competitive exam, you will find out some questions related to strain, and they will mention units after that in one of the options. Don't select that. Strain doesn't contain any type of unit. Okay, strain is a unitless quantity. This is elongating strain, right? So because we are applying load on the longitudinal axis, as you can see, this is the longitudinal direction and this is the lateral direction. So this kind of strain is named as longitudinal strain. And the stress, which is tensile of course, but we can also term that as longitudinal stress, which I have forgot. So please make a note of that. Okay, now while stretching the body, it will elongate in this direction, in longitudinal direction. So generally it must make over from other directions. Suppose if it is it has a rectangular cross section, so generally whenever we are applying load in this direction, so the lateral direction it will get shorted. Suppose like this is a rubber band, as you can see, this is very small. While applying tensile load, it will get reduced in the lateral direction. So there must be reduction in area in the lateral direction. So it looks like this after applying the load. So there must be some sort of deformation in the lateral direction. This is delta D and the actual width is D. Okay, so the ratio of this delta D to D is named as lateral stress. Epsilon lat equal to delta D by D. Okay, so like we have studied tensile stress, compressive stress, shear stress. All those types of stress will lead to some amount of strain. The tensile stress, while applying tensile loading, the strain we named as tensile strain in the longitudinal direction. But since it get reduced in lateral direction, so in lateral direction we will get compressive strain. So if we classify strain, then like stress, it is tensile strain, compressive strain, and shear strain. As you can see, if we apply shear force, there must be some amount of shear strain. Now these all type of stresses and strains, they are can be represented by matrix. Okay, so as you you can see, this is a matrix which is represented various types of space. Each and every term of the matrix I will discuss now. So as you all know, force is a vector quantity, length, width, breadth, all are the scalar quantities. Now stress is another one unusual phenomenon which is neither a vector nor a scalar. This type of elements are called tensors. Okay, so in stress, as you can see, I have used two denotions, right? One like this, as you can see, this is x-axis, this is y-axis, and this z-axis. So similarly, you can assume this axis is like a plane. Okay, now in this case, while representing stress at a particular point, first element is that in which plane the stress is acting, and the second element, like in sigma xx, as you can see from here, this x represents the plane and that this x represents the direction. So while introducing stress, we have three phenomena. In case of forces, we need to know the value as well as direction. In case of length, the value itself is enough to quantify or to define the nature. In case of stress, we need three. First one is the value from V. Second one is the plane on which it is acting, like this x. Third one, this x is the direction. So value, plane and direction. We need all of these three to quantify a single value of stress. Now, what is sigma and what is tau? Sigma termed as the principal stress. What is principal stress and what is shear stress? Detail we'll discuss in our next module, which is compound stress and strain. Please go through that module to understand what is principal stress and what is shear stress for a particular value, for a particular body. Now, this sigma is denoted as shear stress, this tau is denoted as, the sigma is denoted as principal stress and the tau as shear stress. As you can see, in this shear stress, tau xy means the plane is x, the direction is y direction. In this case, the plane is x, the direction is z direction. Now, I request all of you to value all the three quantities of stress for y plane and z plane by yourself, and you can post your images of solved problem in our comment section. I will go through that and I will respond individually. Okay. So this is a stress matrix, as well as we have a strain matrix. From there on, we'll solve some numericals related to that, and from strain matrix, Hooke's law, some elastic constant we'll discuss in our next class. Stay tuned to Aspirants. Thank you.